Hello, I am Dr. B.K. Singh, Professor of Civil Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. So, in this particular lecture, I am going to continue once again the mechanical properties of aggregate and also quality of water for concrete making and curing. So, there are the different tests which has been conducted on the aggregates are particle size and shape, deleterious material, organic impurities, specific gravity, density, voids, absorption and bulking, mechanical properties, soundness measuring, mortar making properties of fine aggregates, alkali aggregate reactivity and petrographic examination. So, most of the portion I have covered in previous lecture. Today I am going to discuss mechanical properties. Okay. So, in mechanical properties. So, what are the mechanical properties which should be tested? So, it should be tested with the help of IS 2386 part 4. So, there is a 6 test: determination of aggregate crushing value, determination of the 10% fines value, determination of aggregate impact value, determination of aggregate abrasion value, determination of the polished stone value and determination of crushing strength. So, out of this I have already discussed determination of aggregate crushing value, and today I will be discussing other properties like determination of the 10% fine values. So, determination of the 10% fine values, this is nothing but aggregate crushing value higher than 30, then find out load carrying capacity of the aggregate by 10% fines value to get proper result of aggregate against crushing resistance. Because once our concrete having a crushing strength more than 30, crushing value more than 30, then the result obtained by crushing value test is not proper. So, we find 10% fines value. Okay, what is the load carrying capacity for that? So, test is similar, nothing different. So, we using the same cylinder, plunger and base plate which is been given in IS 2386 part 4 for determining the crushing value. So, same thing we have to use. So, here we have seen the cylinder, say I am using a cylinder of 150 mm diameter. So, in that case the internal diameter of cylinder should be 152 mm plus minus 0.5 mm and height should be 130 to 140 and wall thickness is 16 mm. So, plunger size will be around 2 mm less than the size of the cylinder, because if you are not using the smaller size, then there is a chances of stucking the plunger with cylinder. So, these are the tests which what we have done here. So, say our value is more than greater than 30 crushing value more than 30%. So, in that case we are taking the same way in the measuring cylinder. If you take the aggregate in 3 layers and compact that with the help of this rod. So, this end is bullet ended end, and diameter of this one is 16 mm and length is about 65 centimeter. So, in this cylinder you fill this concrete in 1 layer, 2 layer and 3 layers. So, each layer will be compacted with this stamping run with 25 blows. Okay. And then you take another and take the weight of this particular sample and similar weight you take for another test. Okay. And suppose our aggregate is rounded or partially rounded, then we have to allow the plunger to move for 15 mm. So, we apply this load here with the help of compression testing machine, a static loading, and we see that it should go down by 15 mm if it is a rounded or partially rounded aggregate. If it is a normal crest aggregate, then plunger should move for 20 mm, and if it is a honeycomb type of aggregate like expanded cells or slacks, so in that case this should move 24 mm. Okay. So, what we have to do, then we have to take the percentage of fraction passing by 2.36 mm will fall within the range of 7.5 to 12.5 mm, but then it is okay. If we have applied the load and we got the movement of around say 20 mm for normal crust aggregate, and we are not getting the values passing value to 7.5 to 12.5 mm, then we have to adjust the loading. We have to adjust the loading by doing another test, so that once again you can get the value between 7.5 to 12.5. Okay. And load required for 10% fines is given by 14 into x divided by y plus 4. So, where x is nothing but load in tons and y is mean percentage fines from 2 tests at x tons on load. Okay. So, then we have to find the load in tons with the help of this formula. So, that is going to give you the values for 10% fines value. So, this is important when the quality of aggregate is not good, or suppose you want to if you are using the value for the purpose of road construction and pavement for runways, that case this value should be less than 30. If it is more for other purpose, then we have to find their capacity with the help of 10% fine value, and that is valid for all types of aggregate. And then we have another test, determination of aggregate impact value. So, aggregate impact value is also very important. Why it is important? Because we may not get the proper crushing value same when the aggregate is subjected to dynamic loading. Okay. So, aggregate impact value gives a relative measure of the resistance of an aggregate to sudden shock or impact, which in some aggregates differ from its resistance to a slow compressive load. So, for that case we have a apparatus, that is here it is shown in this diagram, and it is given in IS 2386 part 4. So, there is a plunger which is having a weight of around 13.5 to 14 kg, and that you have to drop with a height of 380 mm. Okay. So, we have to place the aggregate passing through 12.5 mm 12.5 mm sieve and retained on 10 mm sieve, okay, in this cup. Okay. So, that also you have to gauge with the help of bullet ended rod and in 3 layers, and after that place it in position and lift this plunger to the standard height, and it will be put in the clouch. And here is a sometimes there will be a counter will be given. So, with the help of that counter you can count how many blow we are going to put. So, generally we have to put 15 blows. Okay. So, we have to drop this hammer for 15 times, 15 blows, and after that we have to remove this, and after removing then you sieve this aggregate through 2.36 mm IS sieve, and aggregate impact value is given by B by A into 100. So, where B is the weight passing 2.36 mm IS sieve, and A is the weight of oven dried sample. So, it is dried before the testing, it should be around 100 to 110 degrees centigrade, you have to dry in oven till you get the constant weight. So, this is the general procedure, and now we will move to the another test. So, another important test is determination of aggregate abrasion value. So, aggregate abrasion value, this is also once again governed by the IS code IS code 2386 part 4. So, 3 types of test is there to determine the abrasion value. One is Dowry test, Devil test and Los Angeles test. So, what codes recommends IS 2386. So, abrasion value preferably must be measured with the Los Angeles abrasion test. So, because what is the advantage of this? So, in this one abrasion will take place as well as there is a steel shelf. So, here when it is under movement, so here steel will get collected, and as it will come to this place, this steel ball will come here and it had an impact also. So, this type of test, Los Angeles test, is going to give you abrasion value as well as impact. So, this is giving you more realistic picture. So, this test is recommended by our IS 2386 part 4, and this is the standard dimensions of this machine has been given. This figure has been directly taken from the IS 2386. So, abrasion charging, how we are going to charge this? So, we have a different grading of aggregate, different group you have to make like A, B, C, D, E, F, G, and number of spheres. So, each spheres, how many of spheres? So, for A type of grading we have to put the 12 number of spheres. So, a sphere means it is made of cast iron or steel, and diameter of cast iron and steel sphere varies from 390 mm to 445 about 48 mm sorry. So, diameter of cast iron is 48 mm and its weight varies from 390 gram to 445 gram. So, these are the things we have to consider, and weight of the charge according to the grading. So, you have to put for A type you have to put 5000, So, similarly, if you have a grade is B type, we have a B type, then we have to put the 11. So, if it is a your grade is up to A, B, C, D, then you have to take the number of sphere like this and weight of the charge in this fashion with plus minus 25 to 15 to 25 gram variation. So, for this one we have to take this machine, this will move with the rotation of around 20 to 30 revolution per minute, and for if you having a grade of aggregate A, B, C, D, then we have to take the 500 revolutions. And if here is the counter, with the help of this you can count the number of revolutions, and if our aggregate grading is E, F, G, then in that case we have to take 1000 revolutions. So, for 1000 revolutions, and here also once again speed should be 20 to 30 revolution per minute. Okay. And what is the values? Suppose weight in the test, suppose this is A grade, B grade, C grade, D grade, E grade, F grade, G grade. Okay. So, in this one if it is a passing 80 and retained on 63 mm, then it is under E grade. If it is a 63 and passing 50 to, then it is under E grade. Between 50 and retained on 40, this is a E grade or F grade. So, similarly, we have other grades like this. If you take passing from 40 mm retained on 25 mm, passing 25 mm retained on 20. So, like this we have different size which is retained on the given square holes sieve. So, here this is the grading of test sample report is there. So, how to get the percentage of wear? That is calculated by original weight minus final weight divided by original weight. So, what we have to do after the abrasion, we have to take it the material out and then you sieve through 1.7 mm sieve, okay. And whatever the material remains, that also you have to wash it properly, so that there should not be any error in that. So, after the washing you have to take the material in oven, dry it at a temperature of 100 to 110 degree centigrade, and when there is no change in weight, that case you take that value. So, whatever the original weight you have taken, take the minus final weight divided by original weight multiplied by 100 is going to give you the percentage of wear. So, for aggregate to be used in concrete for wearing surface like runways or highway, we have to use the value not less than 30%. So, this is given in IS 383 1970 code. So, that also you have to download and see the quality of material here. Okay. So, if you see here, if you want for general other purpose, this should not be more than 50%. So, if it is more than 50%, then this type of aggregate cannot be used for concrete purpose. So, that is very very important here. So, this values must be remembered. Then we have to determine the crushing strength, because sometimes we may not be able to get the aggregate, and if aggregate is not available, because first say I want to construct the dam. So, in dam we do not have aggregate now, and we have to see the suitability of that particular rock as a aggregate. So, what we have to do, then you take the test specimen from the rock. So, what we have to do, you have to take the cylinder. So, what should be the size of cylinder? Size of the cylinder should be 25 mm. Okay. 25 mm, and diameter should be also about 25 mm. Okay. So, this cylinder either you can obtain by grinding or by coring. So, either you can core it or by grinding you can get this type of specimen, and then we have to put this specimen in compression testing machine. This and surface must be having a should be leveled. So, undulation should not be there, and you have to keep this vertical position, put this under the compression testing machine and apply the load from here. Okay. So, whatever the load you are applying, and then you apply the load, you will get the crushing value, and crushing value can be obtained in terms of Newton per mm square or kg per centimeter square, and crushing value can be given by crushing strength value is given by force divided by area of this cylinder. Okay. So, with the help of this we will be in a position of getting the quality of this coarse aggregate for crushing strength to get the quality of aggregate. Okay. So, now we will discuss quality of water. So, quality of water is very important, and because strength of concrete depends on the quality of aggregate. So, water used for mixing and curing should be clean and free from injurious amount of oils, acids, alkalis, salt, sugar, organic materials or other substances that may be deleterious to concrete, reinforcing steel, pre-stressed tendon, wires, cables. Because what will happen if the quality of water is not good. So, what will happen with the help of if you are using the water which is not qualifying, that is going to reduce the strength of the concrete, and not only reducing, they have a long term effect. Suppose there is a chloride or sulphate in the concrete, chloride, what will happen? This chloride is going to create corrosion in the reinforcement, and the life of the structure will be, durability will get affected. And similarly, if the sulphate is more, that is also going to cause expansion, and finally reinforcement will get affected. Okay. So, I am staying in Dwarka, Delhi. So, the building has been constructed around 25 year back, 25 year back, and most of the building is showing sign of cracks, because most of the builders have constructed a house there with the groundwater, and that groundwater contains more percentage of chlorides and sulphate than permissible limits. So, that is a cause of creating cracks in the building. And I had earlier spoken that Mandoi Bridge in Goa collapsed during the working condition in 1986, because they have used not water, but admixture there which was carrying chlorides. So, in working conditions, that admixture they have used for grouting the tendon, and that tendon caused corrosion due to the effect of chloride. So, water also if is having a more percentage of chloride, certainly it is going to create the problem. So, IS, if you go to IS 3025 part 22, so this says you have to take the 100 ml of sample of water, use phenolphthalein as an indicator, and it should not require more than 5 ml for 0.02 normal sodium hydroxide. Similarly, if you go to IS 3025 part 23, to neutralize 100 ml sample of water using mixed indicator, it should not require more than 25 mm of 0.02 normal H2SO4. So, this is the IS specification is given in IS 456 2000. So, that must be verified. Okay. And we have limitation of solids in water for construction. So, here also as per IS 456, these are the limitations they have given. So, organic matter should not be more than 200 milligram per liter, that can be tested with the help of IS 3025 part 18. Similarly, inorganic matter should not be more than 3000 milligram per liter, that is also governed by the IS 3025 1964 part 18. And sulphate SO4 alkali chlorides, that should not be more than 400 milligram per liter, that is given in IS 3025 95 part 24. And chloride, this is also 2000 milligram per liter, and suspended matter should also not be more than 2000 milligram per liter. So, that governed by part 17. So, if you want to read this in details, we have to download this IS course, this is also very important. So, once we are going to study the concrete technology, we have to refer so many IS code books, IS code books. Okay. And test for compressive strength. Suppose we want to use the water and want to determine what is the strength criteria. So, what you have to do? You have to take the cube, make a cube of size 150 mm by 150 mm by 150 mm with the water which is intended to be used, and similarly you make another 3 cubes. So, how many cubes you have to make? 3 cubes, at least 3 cubes, and again you take another 3 cubes which will be made with the help of distilled water, and you test according to IS 516, according to IS 516, because there is a certain procedure has been laid out to test like speed. If it is a load control machine, their speed of loading, rate of loading should be 140 kg per centimeter square per minute, and how to keep this place, all this procedure has been laid. So, you have to go through the IS 516 for testing, and if this intended, suppose I want to get around say our value should be around 30 Newton per mm square. Okay. And if you are achieving 90%, okay, 90% average, then we can say it is okay, we can use that water for a strength criteria. And similarly, test for initial setting time. So, initial setting time is made, test is made with the test will be done with the help of Beckett appraise test governed by IS 4031 part 5, and we have to take once distilled water and another the water which is supposed to be done for the testing purpose. So, in both the case their variation should not be less than 30 minutes. Initial setting time in that case should not be less than 30 minutes, and even with the distilled water and with the intended water which is to be used should not differ more than 30 minutes. So, that is the requirement of this requirement is of IS 456 2000. So, this one also we are supposed to do, that is very important here. So, generally whenever we are using the water, the general purpose is we should be potable water, means it should be safe for drinking. If water is safe for drinking, then it is safe for using for the concrete also, and making the concrete as well as for curing the concrete, both case at least we should use the water which is potable in nature. Okay. And if you want to use sea water, because potable water is not available for that purpose, then that can be done only for the purpose of plain cement concrete, and generally it should not be used for pre-stressed concrete and RCC. Thank you.